In this case, we are going to consider a continuation working with the parabola, which is the quadratic graph, the quadratic function. All right. So with the information that you have about the previous graph that we referred, which was a straight line graph, what we understand so far is that for us to plot or to draw a certain graph, what is important are points. The points which are marked on the graph are the ones that we are simply going to join to produce a straight line. If it is a straight line, all right, whatever graph that you are going to have, it is from what? From the given points. You produce it from the points that you have marked on the graph. So on a quadratic graph, which is our parabola, in this case, it is something that is of this nature in terms of the shape. We're going to have something of this nature or something of this nature, quadratic, from the function ax squared plus bx plus c. Remember the quadratic function presentation. So when we are given this format, we know that we are dealing with a quadratic function where the highest power is 2. On the what? On x. The highest power on x is what? Is 2. So this can also be obtained if we are given two brackets where we have got x, maybe x plus a, and another one is x plus whatever that you're given, but we've got two brackets in x. The x and the x, when this is multiplied, is going to give us what? X squared. So you know that when you are given brackets as well, two brackets like this, in what? In x, where you can multiply x and x to obtain x squared. Not to say there is something like this, because if you're given something like this, guys, yes, there are two brackets, but if you multiply the x and the x squared, it's going to give us 2x cubed. It's no longer a quadratic. So the issue is when you expand everything, you must go back to the x squared. So whether you're given x into 4 minus x like this, if you multiply, this is going to give you 4x. If you multiply here, it's going to give you negative x squared. So you're back to what? A quadratic graph. So you can just expand the brackets so that you can properly see the presentation of this quadratic notation that we are used to. So that is basically what you are going to consider of a quadratic or a parabola. So from this, A, B, and C are constants, right? So that is A, B, and C are what? Constants. These are simply constants, whereas x and y are variables. So the x and y are simply variables. We're not going to have any substitute for that, all right? So what we can have here is the part of x, the part of a, b, and c, something like y is equal to 2x squared minus 3x plus 4, where these are simply what? Are simply constants, all right? And C is also important on our equation. This C here is the y-intercept, where the graph is going to cross the what? The y-axis, the y-intercept. So that is at point what? At point C. So this C here is the y-intercept, all right? So that is the y-intercept, where x is equal to what? X is equal to 0 in the y-axis. And this part of B is going to help us in determining the axis of symmetry, which is going to help us at the turning point. This is that we're going to talk about that later on. So this A here is for the shape. So A is going to help us for the shape. So A is simply used for the what? For the shape. When A is positive, when you have a greater values, when A is greater than 0, that's being what? Positive. When A is greater than 0, your graph is going to look like this, which is what? Concave up, going up like this. It is facing up. It is what? Concave up. All right. So this is for A is greater than 0, where we are referring to positive values, 1, 2, and so on, as long as it is what? A positive value. And when A is less than 0, this is the shape that you're going to have where the graph is facing down. So this is concave down. So it is concave what? It is concave down. This is the condition that you must actually understand when you are working with a quadratic graph, a parabola. The shape is very important. So A is for the shape, like I said. So this helps us when we are drawing our graphs to say, okay, we must expect something like this, just to know the shape and also the y-intercept. But in order for you to end up with a quadratic graph, always you are going to apply or to use table of values. Table of what? Values. That is to draw a what? Quadratic graph. So that is basically what we are going to consider throughout. Table of values throughout. All right. When you are given, you'll be given actually for us to use the table of values, you'll be given an interval for x. X is to be taken from -4 up to +4. Those values of x are the ones that you use. Remember, x values represents what? The input. So you're going to insert the input values so that you obtain what? The y values at the end. So that's basically what you are going to do always, guys. All right. So in this class, I'm not going to dwell much into aspects about the quadratic graph. We are going to look into that after we have drawn and we understand the shape. Then we are going to look into a lot of things actually about this quadratic graph. We are going to look into that. All right. So basically, let's say we have got something like this. All right. A graph of y is equal to x squared. All right. If it is drawn, like if let's say we have drawn this graph, there are so many things that you must consider, such as turning points, axis of symmetry, the solutions, the gradient, the area. So those aspects now are the ones that I'm saying, okay, for now, let us leave it. Let us consider just drawing this and just I'm just going to explain one or two aspects. So you must follow these classes up to the end so that you can understand, all right, other aspects that you can be given. All right, so using this part, I'm going to illustrate, all right? So I want us to work out the graph of the first one. We're going to use y is equal to 3 plus 2x minus x squared. So you'll be given the equation y is equal to this, or you're given this as f of x is equal to, it's just one and the same. So in order for us to draw or to plot the graph at the end, which is a quadratic graph, as we can see, the highest power on x is what? Is 2. So that's a quadratic graph. And from this presentation of y is equal to ax squared plus bx plus c, if we are to write in that form, this is simply the same as negative x squared, all right, plus 2x plus what? Plus 3. That is the same presentation as you can see here as it is. So the coefficient of x squared is what is important. Remember, our a is for the what? The shape. So in this case, it is a negative value. The coefficient of x squared, that's what? -1. So our A is equal to -1, meaning to say we're talking about values which are less than what? 0, where our graph is going to be what? Concave down. So this is the shape that you must expect to have at the end of the day. All right. But anyways, like I said, guys, all this, even if you do not understand from the points that you'll be given, you are still going to what? Produce the same shape as it is, all right, without the knowledge or with that knowledge. So you'll be given the table of values, sometimes complete, sometimes not complete. When it is not complete, meaning to say you have to find what? The missing values. So in this case, let us use our table of values complete, all right? So let's say we are given the table of values. You'll be given this, all right? They will give you the table of values and also the scale to use, all right? So this is -2, -1, okay, 0, 1, 2, 3, up to 4. All right, so let's take this one up to what? Up to 4. So you are going to, all right, actually you'll be given, like I said, these values, and sometimes maybe they can just ask you to find the missing values, maybe two values that are missing. So let's say you are given or not, all right? What you need is to find all the output values, which are the y values from this function that you are given. So y is equal to 3 plus 2x. So this part here, we are going to put the value of x minus what? X squared. So we're going to put the value of x here, but being what? Being squared as we are given here from this presentation. So the first part, our x is what? -2. When x is -2, what is the corresponding y value? So we're going to substitute in place of x, you put -2, -2. Just like that. So this is how you play around this type of a question. So you can substitute these values, all right? Use your calculator, or you can simplify this the way that you understand. You obtain what? The y value at the end, all right? So let us substitute this into our calculator. 3 plus 2 into what? -2, all right? Minus our x value is what? -2, but we're supposed to square this. So this is going to give us what? -5. So that is the y value corresponding -5. So this is what you're going to do for the next value. And x is what? -1. You simply do the same thing in place of x. This time we're going to put what? -1. So that is how you play around with this type of a question. All right. So here, just going to put -1. All right. Let us put -1 here. So that is going to give us what? A 0 at the end. So y is equal to 0. So that is it. You do the same. On x is 0, you do the same thing. Put 0 there, guys. Okay. Your y value was going to give you 3, and this was going to be 4, and this was going to be 3, and this was going to be 0, and this one -5. So after that, you can draw or plot the graph that you are given. Definitely, they are going to give you a scale to use or to apply in that presentation. So here, let us say we're given a scale of 2 centimeters to represent 1 unit, all right, on the x-axis, okay, for which our x is greater than or equal to -2, less than or equal to 4, and okay, for y-axis 2 centimeters to represent, let us use 2 units, right? For what we are given, let us just use 2 units. All right, 2 units. All right, on the what? On the y-axis. So this is what you're going to use. And for that, we're going to take our y values to from negative. All right, so here we cannot take from -5 up to 5. This was -5. All right, this is negative 5 again. So let us just take from negative 5 up to what? 4. But for the y values, definitely this is not important. What is important here is what? The scale. For the x-axis, that is the one that they are actually going to give you what? The interval from where to where. Then the y values, you can work with what you have on your table to see, okay, the minimum value that I'm having on the y is what? Minus 5. This is our minimum value, minus 5. And the maximum value, according to what we see here, is what? Is 4. So meaning to say, you must just accommodate on your scale minus 5 up to what? Up to 4. You can see that on the output values, the y values, from minus 5, the minimum value, up to 4. So meaning to say, minus 5 up to 4, according to this scale that you're given, 2 centimeters to 2 units on the y-axis. This is minus 2, minus 4, minus 6. So we put minus 5 in within, all right, up to 4. So this is 2, 4. All right, we have got that 4 there. Okay, just write 6. It's not a problem. Right, let's see the x. We said 2 centimeters to represent 1 unit. All right, from minus 2 up to 4. So can we accommodate 4 here? 1, 2, 3, 4. All right, so we have got that 4 and negative 1, negative 2. So that is our Cartesian plan. With this, you can mark the points just like what you had before when you were working with a straight line. So if you do not understand about marking the points, please watch the first video under these algebraic graphs when I explained about the coordinates. All right, so please do so that you do not miss. All right, so that is it, guys. Let us mark these points. The first one, minus 2, minus 5. X is minus 2, y is minus 5. So you mark that. Minus 2, minus 5, definitely in between minus what? 4 and minus 6. So you just have to count 5 boxes going down. So this is minus 5, and this is minus 2 for x. Where they meet, you mark a point. So minus 2, minus 5. X minus 2, y is minus 5. All right, let us move on to the second point, which is minus 1 versus 0. Minus 1 versus 0. X is the one that you're given. So you mark direct on the x value at what? Minus 1. On the x-axis at what? Minus 1. That's minus 1, 0. All right. So this is it. You mark the second one, 0, 3. 0, 3. What you're given here is the y value. The x is not given, so y is 3. So you mark straight in the y-axis at what? At point 3. Direct in the y-axis in between 2 and 4. So that's 0, 3. All right, so this is our point what? 0, 3. And let us have another one, 1 versus 4. X is 1, y is 4. So where x is 1, y is what? 4. They meet at that point. You mark the point 1, 4. Okay, just like that. So you move on. 2 versus what? 2 versus 3. When x is 2, y is 3 here. 2 and 3, they meet at that point. So you mark the point 2, 3. Another one, that is what? 3, 0. So the x value is the one that is important, 3. Since y is not given, x is what? X is 3. So that is x is 3 in the x-axis. X is 3 here. You mark the point. And the last point, 4 versus what? Minus 5. 4 versus minus 5. X is 4 and y is minus 5. In between here, they're going to meet. So where they meet, you mark a point 4 versus what? Minus 5 in between here. Okay, something like that. So this is it. With these points, we have marked all the points that were given. You are going to join them with freehand. You join by using what? Freehand. So that is what you're simply going to do when you're using what? The table of values method, right? So use table of values to draw the what? The quadratic graph. So here you simply need to mark all the points. You simply mark all the points from what? From the table of values on the graph or on the Cartesian plan. on the Cartesian plan. All right, then join using freehand. So you simply join using what? Freehand. A smooth curve. A smooth curve must be produced. So you must produce what? Smooth curve. A smooth curve. Very smooth. So make sure you use a sharp pencil, all right? And try by all means to produce what? A smooth curve by joining what? These points. So these are the points that you're given. Let me try minimize and see if I can join these properly. So with these points from here, you just need to join like this to this one, to this one, to this one, back to this one. But you must do it with the free hand, it must be smoothly, not glossy. All right, smoothly, not gross. So let's just try from here to here. So here, guys, it's because, guys, I'm using digital platform here, so I cannot have it as smooth as you are supposed to actually obtain. So here, this is the turning point. Remember, it is like this, so it is a curve. So you must have a curve there. At that point. It must be the same way that it was this side, the same way going down on the other hand. So you must have a curve. This one, it is supposed to be our turning point. So you must just try to join properly. All right, from this point to this point, so that you can have what? The curve. All right, a curve like this. So guys, this is freehand and it must be smooth. All right, then from here to this one, and from this one to this one, just like that. Okay, something like this. So mine is not as smooth as it is supposed to be. It's only because here, guys, even if I try to use these, they won't give us exactly what we want. Let's try. You see, guys, it won't even try to bend to that part that we want. So here, I'm just gonna leave it, guys, as it is. Let me see. Maybe I'm the one who is telling it that it won't, yet it can. Let's see if we're gonna do this. But now you see, guys, I have to do a lot of adjustments in order for me to have that, and it won't even work here. You see, guys, it won't even work. So that's definitely something that we cannot have here. It's gonna take a lot of time. So just try, guys, to have something which is smooth like this. All right, so maybe something like this, and have the first half. So this can be our first half, this one. So you see like how it's supposed to be like this. So there is not much difference from what I had using the freehand, of which you're not supposed to be that smooth. Yes, it is the smoothness, because it is going to affect our calculations later on. So you can try, I don't know, guys, using the refill. Some they use that refill to produce the smooth curve, whatever way that you are going to use, but make sure that you have what? A smooth curve. All right, so that is the graph that we had, our quadratic graph of, we have to write its equation, the name of that graph. So that is of y is equal to 3 plus 2x minus x squared. As we can see from that negative and also the shape, we can see that it is what? Concave down, as it is like this. And from this graph, there are so many properties that we are going to explain later on. But for the meantime, what we can see is the turning point where the graph what? Where the graph is symmetrical, where that is at the line of symmetry, where the graph is divided into two equal parts. All right. So at the line of symmetry, that is at the turning point at this point here, you can see that is the line of symmetry. By just looking into the graph, guys, you can see that this half here from here to this point, that's a half, and this one is another half. But by calculation, you can determine the line of symmetry by what? By calculation, the line of symmetry. All right, let me write these notes on this page here. So this was on the drawing. So this is just an extra part. All right, the line of what? The line of symmetry. This one, it divides the graph into two equal parts, right? It's going to divide our graph into two equal parts. So as it is a vertical line, therefore its equation is given in the form x is equal to something, all right? Since we are talking about vertical line, remember those are the lines x is equal to 1, x is equal to 2, something like that. So at that turning point, that is where we have what? The line of symmetry. So the line of symmetry passes through the what? The turning point, which is given by the equation x is equal to minus b over 2a. So this is the presentation of the line of symmetry, its equation from the format of a quadratic graph. Y is equal to what? Ax squared plus bx plus c. If we take minus b over 2a, we are going to have the equation of what? The line of symmetry. So just for an example, from this graph that we are given here, y is equal to this part. Remember, here I said we can write it as minus x squared plus 2x plus what? Plus 3. Minus x squared plus 2x plus what? Plus 3. So we can see that from our format ax squared plus bx plus c, our a is what? Minus 1, the coefficient of x squared. B is the coefficient of x. So our b is what? The number that is affecting x here. This one, positive what? Positive 2. That's our b. So given a and b, you can have the value of x given what? The equation of line of symmetry. We can obtain that the equation of line of symmetry, x is equal to minus b over 2a. So x is equal to minus, our b is what? 2 over what? 2 times our a. Our a is minus 1. So that was going to give us the x value, minus 2 over 2 times minus 2. 2 times minus 1, that's minus 2. So this cancels. You're going to get what? A 1. So x is equal to 1. That's the equation of what? The line of symmetry, where x is 1 here. The line of x is equal to 1 is simply what? A vertical line that is that we can have here. All right, let's see, simply a vertical line, all right, drawn passing through the point where what? Where x is equal to 1 here, passing through the point where x is equal to 1. So you can even write its equation, x is equal to 1. That's the line of what? Symmetry. We're talking about the line of symmetry here. The line of symmetry. This is what you're referring to. So from that line of symmetry, saying the turning point where the graph is stationary there, the turning point, at that point, x is 1. So to obtain the turning point, you simply use what? The line of symmetry. And at that turning point, if our graph is like this, concave down, we have this one as our turning point. And at that turning point, the y value represents the maximum value. When it is concave down, it is of this nature, it is just like a hill. You see that, guys, a mountain or a hill, the shape of a mountain. So when you're referring to the mountain or a hill, you talk about the maximum value going up. When it is like this, just like a sea, you talk about what? Minimum values going down. So from what we have here, this shape, the y value that we are going to have is the maximum value. But remember, this is happening at the turning point where we know the value of x. So we can simply substitute that value of x into the given function to obtain what? The y value which is at the what? Turning point. And that y value is the maximum value according to the shape that we are having here. We are referring that as the maximum value. So where x is what? Where x is 1 at the turning point, that is the condition. So here you use that concept for the what? Turning points. All right. So whenever we are to deal with the turning points, you must take note that at the turning point, x is equal to minus b over 2a, just like what we had here. So using that x value, substitute it into the original function to obtain the y value. All right. So you simply have to substitute the x value, substitute the what? X value to obtain the y value, at the turning point, just like that. So you substitute the value of x that you calculated to obtain the y value at the turning point, which can be maximum or minimum. So when it is like this, we are talking about what? Maximum. When it is like this, you're referring to the minimum. So at the minimum turning point, at the maximum turning point, it means the y value is maximum. That is what you must take note. The y value is what? Is maximum. At the minimum turning point, it means the y value is what? The y value is minimum. From the turning point that you are using, it also tells us about the y value. So I'm not going to dwell much. Like I said, we are going to look into other aspects later on. This is just for an introduction. Okay, so that is what you're going to have here. So meaning to say, for the turning point of this graph, it is simply going to happen where x is what? Where x is 1, the one that we calculated. So the y value can be obtained by substituting into the what? Into the given function, the value of x at the turning point. So remember, we said x is what? 1 at the turning point. So by substituting that, we can see that our y value is going to be equal to 4, of which we did this one before. All right, so y value is what? 4. So that is the turning point. X is 1, y is what? Y is 4. So that value of y now, the one that is corresponding here, is the one that is we are referring therefore is this one. That is our maximum value according to the shape, maximum. So meaning to say the maximum value of the function, maximum value of what? The function, maximum value of the function or the graph that we are given is going to happen at the turning point. This is simply at the what? At the turning point, at the maximum turning point. What is the value of y? That is what? 4. So simply from our question here, y is equal to 4 from this graph that I'm explaining. That is the maximum value of the function or the maximum value of the given graph. You are referring to the y value at the turning point. All right. So all these aspects, you must understand them, all right, in general. All right. We are going to add other aspects in the next class, but for now, I want you to understand these basics. And also as of the shape, we saw that when the coefficient of x squared is a negative, our graph is what? Concave down. So let's look into another question where we can apply the coefficient of x squared being what? A positive. And in that case, our graph is going to be what? Concave up. All right. So using this, let us quickly have another one. So I'm going to use these two graphs in the next classes for other aspects that we can be asked on a quadratic graph. All right, so here I'm going to use the second one. Y is equal to 2x squared minus 3x. or they give you this one as f of x is equal to, it's just one and the same. So as we can see from our graph here, the coefficient of what x squared, as we are to refer to this x squared, its coefficient is what? 2. The number that is affecting x squared here, this one, 2. Positive, we are referring to a number that is what? Greater than 0 from our format, guys. Ax squared plus bx plus what? C. Our a here is what? Is 2. So thus greater than what? 0. So this is supposed to be what? Concave up. So I'm just going to apply this one as a second example so that we can just see if truly we are going to have something like this. That is what concave up, but we can see that is what is happening. And from the explanation that I have just given you guys, and like I said, they will give you a table of values, whether it is complete or not. All right, when it is not complete, you fill in the values. All right, so here I'm just going to give you a complete table of values for this graph. All right, from -2 up to +4, -2, -1, 0, 1, 2, 3, up to 4. All right, something like this. And the output values, which are the y values, let's say this is 14, 5, 0, -1, 2, 9, 20. Okay, so let's say this is what we are given. So I'm just gonna represent this, all right? And also the scale that we can actually use, all right? We're gonna use 2 centimeters, all right, to represent 1 unit, all right? So let's use 1 unit on the x-axis to represent 1 unit on the what? X-axis. So this is on the x-axis, and 2 centimeters to represent. All right, so we're gonna use 5 units. All right, 5 units, 2 centimeters to represent 5 units on the what? On the y-axis. Okay, so definitely for x, we're going to take from -2 up to 4. We can see that from what we're given. So that is it, 2 centimeters. Okay, let us see our Cartesian plan here for the x values up to 4. Yes, we're going to win 1, 2, 3, 4. So that's it, 0 here, 2 centimeters, 1, 2, 3, 4. Okay, and -1, -2. All right, on the y-axis, 2 centimeters represent 5 units on the y-axis, that is going up to, you can see for the y values, let's say the minimum value that we must accommodate is -1, whereas the maximum value here is 20. So we need to say we must accommodate -1 up to 20 using 5 units, all right, using those 5 units. So -5 accommodates what? -1. It is in within, so we are done. So let's go up to 20. So that is 5, 10, 15, 20. Okay, which is very important now because of this scale that you're given and also these values. We must understand our scale before we are to plot the graph here, all right? So this is it, we're done. So according to scale, let us try to understand this scale, what actually it means here, okay? So we are saying 2 centimeters represent 1 unit on the x, of which on the x, it is not an effect because they are what? They are all, these numbers are all represented here, 1, 2, 3, and so on. But just in future revision, when you are given this scale, remember I told you 2 centimeters is what? The 10, those 10 small boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So when you're saying 2 centimeters represent 1 unit, what about the smaller, the smaller, this one, this, that smaller box? Because here we talk about those 10 boxes. representing 1 unit. So to obtain 1, it means you're counting 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 0 0.6, 0 0.7, 0 0.8, 0 0.9, 1. So each box now will be representing what? 1. Each smaller box will be representing 0, 0.1. So you can actually have it this way, say 1, all right, 2 centimeters, sorry, here 2 centimeters represents what? 1 unit. 2 centimeters represents 1 unit, which is those 2 centimeters, in actual sense, there are how many boxes? 10 boxes. So you can write it in the way that you understand. 10 boxes, they represent 1 unit. So since we are back to 1, guys, we cannot okay, what about 1 again? It's already 1. It's different from this one, 5. Then you ask yourself, what about 1 unit? In this case, maybe you can just try to understand what 1 box represents to say, what about 1 box? It represents what according to the scale. That is how we can reduce this. What about 1 box? So as you can see, 1 box definitely is going to be what? Less. So it means the lesser value over what? The bigger value from our proportion. 1 over 10 times what? Times 1 unit. So this is going to give us 1 over 10. It's what? 0, 0.1. 0, 0.1 times 1, that's what? 0, 0.1 unit, which is what I was explaining. Say this is 0, 0.1, 0, 0.2, 0, 0.3, 0, 0.4, 0, 0.5, up to 1. So when it is 1 here, you cannot go as much as this in most cases, all right? So this one, do not worry in most cases. But when you are given other values, 2, 4, 6, all right? 5, 10, like what you can see on the y-axis, the 2 centimeters represents what? 5 units. Those 10 small boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we are told that they represent what? 5 units. So in this case now, that is where you can ask yourself, what about 1 unit? Just like this is 1 unit, which was represented here now. Here is represented as 5. Here is written as what? As 1. So that is where you can ask yourself, what about 1 unit? On the y-axis, it is represented by how many boxes? If these 10 small boxes represent what? 5 units. If the 10 small boxes here represent 5 units, what is it that you want to understand when it is? You want to understand 1 unit is going to be represented by how many boxes? That is by calculation, by someone can just look into the graph and say, all right, if I divide these ones by 2, say 2 boxes 1, 2 boxes 2, 2 boxes 3, 2 boxes 4, 2 boxes 5. So it's 1, 2, 3, 4, 5. So 2 boxes actually represent what? 1 unit. But mathematically, you can do it here to say 10 boxes, they represent 5 units. What about 1 unit? It is equivalent to how many boxes? How many boxes here will represent 1 unit? So that's definitely going to be less. So that's 1 over 5 times what? Times 10. 1 over 5 times 10 boxes. Your answers must be in terms of the boxes. So that's 10 divided by 5. It's 2 what? Boxes. So for for every part, when we count 2 boxes, that's a unit. 2 boxes for the y-axis, 1, 2, it's a unit. So if I move again, 1, 2, another unit. So this will be 2. So it's like this, guys. After 2 boxes, all right? 2 boxes here, that is what? 1 unit. So it is just like that. 2 boxes, 1 unit. You count again, 1, 2, 2 boxes, 1 unit. So this is 2. This is now 3. 2 boxes. This is what? 4. 2 boxes going up. You end up at what? At 5. So that is what? The 5 that we are having here. So this is basically what you're simply working with. 2 boxes will represent a unit. So it's 1, 2, 3, 4, 5. The same way that you're counting 1, 2, 3, but here you are counting it after 10 boxes. Only that on the other side, one is counted after two boxes. Two boxes there, two boxes, like that. So you must be very careful on the presentation of what the scale, how to interpret that scale actually. All right. So, anyways, now that we understand our scale, let us mark these points. All right. So we're not going to have a problem. We simply know that for the y-axis, 1 unit, we said 1 unit is represented by what? By two boxes. Two boxes represent 1 unit. It is equivalent to what? Two small boxes, all right? So whenever we have that, guys, remember it, all right? So let's mark our point. -2, 14. -2 and 14. X is -2. Y is what? Y is 14. Where do we have 14? If two boxes represent 1 unit, it means 14 from this 15, we just need to count two boxes going down. So 14 is here. So this is our 14. And this one is going to meet here. You mark a point. So 14, just two boxes below it. Just two boxes below this 15. That is where our 14 is. And the -2 in the x. So they will meet at that point. Where they meet, guys, you mark a point. So that's somewhere here. Okay, so this is our 14. Two boxes represent 1 unit, just like that. So let's move on to another point. Sorry. So that's -1 versus 5. This one is direct. -1. All right. Y is 5 here. So this one is direct. You mark the point. Okay. That's -1 versus 5. 0 versus 0. And x is 0. Y is 0. That's the origin. Okay. We move on. 1 versus -1. Okay. So this is 1 versus -1. So -1, it is actually a big guys. 1 versus -1. Remember, we said it is what? The smaller, the one that we are referring to. All right, let me just remove these guys. Okay, when we are referring to 1 on the y-axis, it's what? 2, those two small boxes, 1, 2. So this is -1. So minus, right? So this is 1 on the x, all right, and -1 on the y-axis. So they meet here. So where they meet, you mark a point. So it was going to be somewhere here, 1 versus -1. So -1 is actually 1, 2, two boxes. Remember, two boxes in the y-axis represents 1 unit. So you must be very careful. 2 versus 2, again, there you must be careful on the scale. Y is 2, all right? So x is 2, y is 2. So 2 on the y, you have to count two boxes, that's 1. Then two boxes, that's what? 2. So this is 1, 2. So 2 versus 2 is like this. This is what it simply means. So that's when x is 2, y is 2, you mark a point. Okay. Then another one, 3 versus 9, when x is 3, y is 9. So 3 here, but y is 9 just before 10. So that's two boxes before what? Before 10. Two boxes, remember. Two boxes represent 1 unit on the y-axis. So two boxes, 3 and 10, somewhere there. 3 and 9, I mean. So this is our 9, two boxes from 10, and this one straight to 3. So that was going to be your point. And another one, 420. 4 versus 20, this is direct as we have 20 there. So we're just going to mark direct when x is 4 going up, y is 20. They meet here. So where they meet, you mark a point. So that's it. These points are enough for us to have the quadratic graph, which is our parabola. That's how you play around with these graphs. All right. So you simply join Just like before, we saw that we're going to join these points using freehand, and we must produce a smooth curve in joining the points. It is not just about joining the points. You must produce what? A smooth curve in doing so. So as you can see, our graph was gonna have a turning point. It was gonna be something like this, and it must be a curve to this point. Then it goes up. Okay, and now it goes up to this point. Okay, so we're going up to this point and up to the last point. So you can do this, guys, in a better way. Actually, you can have a smooth curve, more smooth than the one that I'm having here, but it was going to be something like this. You have got your quadratic graph, your parabola of y is equal to 2x squared minus 3x. All right, so you write down what you have there. The equation y is equal to 2x squared minus 3x. Okay, that's what you have. So as we can see, this time our graph is what? Concave up. That is what we have. Our graph is concave up, facing up. So it's about the shape. The shape. Okay, so I want you to be very careful about this. And like I said, we are going to consider other questions later on from these graphs that we have drawn from the table of values. So here, I just wanted you to see the shape, how it can look like. Okay, so this is how we can actually have our graph. Okay, concave up. And like we had before, this one concave down, all right? So that is the basic concept. So do revise in as much as you can, working with the basics, all right? So these are just basics, the shape of the quadratic graph. So with these graphs, we shall meet again in the next class, looking into other aspects.